function f of x. I don't care what the equation is. We have the graph. We're going to sketch the derivative graph. Okay? So, there's a few points on here that we know what the derivative is. What points do we know what the derivative is on this graph?
The max and the min.
The max and the min. What is the derivative at a max and a min? 0. So, on the derivative graph, they have values of 0. So, those are the x-intercepts. So, you can essentially just mark them right there. So the maxes and the mins will become the x-intercepts on the derivative graph. Now, look at then you break the graph into quadrants. So we're going to look at this bit of the graph here. What is the slope of this graph? Now, I don't care about the number. All I care about is the slope, positive or negative. Slope on this part of the graph is positive, right? If you're rising from the left to the right, that's a positive slope. If the slope is, so this is a positive slope. Positive slope. If it's a positive slope, what does that mean the derivative is? Sorry? Positive, right? Positive slope, therefore, f prime of x equals positive. That makes sense, right? Yes?
It does, but why again?
The slope is the derivative.
Oh, okay.
All right. So it's positive. Now, if you're positive and you're sketching a graph, are your values above the x-axis or below the x-axis? If your values of the function are positive, are those points above the x-axis or below the x-axis? Above. And can we see that? Actually, let me draw it on the thing. If we are the slope, you can't see that. The slope here is steeper than the slope there. Do we agree with that? Steeper. Like it's a bigger number. Like I could say m is equal to 5. I'm just making that number up. M here, this red one here would be, I don't know, say 1. Do we agree with that? So we know that the values are positive and they're getting smaller as they get closer to this point because the slope at that point is 0. They're positive and they're getting smaller. So that means the derivative graph is coming down like that. Positive numbers above the x-axis, but getting smaller, so they're getting closer to 0. So that section of the graph on the derivative looks like that. Before you get all confused, let me finish the graph first. Okay, now, next section. This part. So from here to here. Is that slope positive or negative? Negative. If you're negative, are your values above or below the x-axis? Below. So, and what's the slope? The slope here, m is equal to 0. The slope here is m is equal to 0, right? So they're all negative, and they have to start at 0 and end at 0. I.e., it has to start there, which is where we are, and it has to end there, right? So it's got to curve back like that. So it's got to go like this. It has to go through those 2 points. What is the slope of the line in the next section, in this section? Positive, right? Yes? That's a positive slope from here up. So it has to be above the x-axis. That is the derivative graph, the yellow one. Now, if you think back to Math 12, what the white one, what type of function is this? Okay, don't think of trig, think of polynomials.
Four? Four.
x3. It's a cubic graph, right?
I thought cubic was the one with the little. I literally said that. Uncertainty. It goes up and then it like.
That's the basic cubic one. I don't like this is some sort of cubic because it's been stretched and stuff. It's x cubed plus blah 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 blah. I don't care what it is. Okay? Does that make sense? Does everybody understand that this is what a cubic graph, cubic polynomial looks like? Okay. When you do the derivative, what happens to the exponents? They go down by 1, right? If I take this and I go down by 1, what do I get? 2. A quadratic. A quadratic. Okay, so it makes sense, right? If I did another derivative, what would the graph, if I took the second derivative, what would the yellow turn into? A linear line, right? Because it would be degree 1. Does that make sense?
Yeah.
Okay, we're going to do it again. All right. Make it nice and big. All right.
Wait, if it was just one curve, would it become it's just like a linear line?
If it's a parabola, it'll become a linear line.
So it just goes 1 degree down.
Because that's what you do when you do a derivative, right? You take 1 away from the exponent.
Okay, that makes sense. Okay, yeah, no.
You can once you see it, it kind of makes sense. All right. So what's the degree of this one?
4.
4. So if we take the derivative, we're going to get a cubic. So we know what the shape should look like, right? We're not going to try and we're not just going to sketch it because you don't know what the function is. So we're going to use this to sketch it. But we should know if we get the right shape at the end of it. Okay. So what's the first thing you mark? The maxes and mins, because you know those become the x-intercepts. So this point right here, I should have made it right at the origin, but whatever. Moves there, that point moves there, and this point moves there. There's your maxes and mins. Those are essentially what you just marked were your critical numbers, right? So now this, if you want to think of it, is that interval that we set up. So now you test the sections here in the interval. So what's the slope of this line? Positive or negative? So the graph of the derivative has to be above the x-axis, right? So you know you're coming down like that. What about the next section? Positive or negative? Negative. So we're looking at those two, right? You have to go through this point. So it's going to dip below and curve up. Now, how far it dips below, that's dependent on the actual function. I don't care. Okay? So the graph comes down, does that. What's the slope in this section? Positive. So but it has to go through this point too, right? So it's got to curve back. Whoa. And then after this point, this slope is?
Positive.
Negative. The graph is going down, but these are negative slopes. So it just continues like that. Does that fit what we thought it would be? Yeah, because that is a cubic graph, right?
If the slope keeps going down, why is the derivative isn't the slope just one number?
No, because this is a curve, right? The slope is changing.
It keeps changing.
Yeah, because this is a curve. You're going to see in a sec one that has a straight line in it. All right, so these are curves, so it keeps changing. That's why it gets steeper. Okay, so the white one is f prime of x, and the yellow is f of x. Do we feel okay about those? Maxes and mins become your x-intercepts because they have slopes of 0. And then you just look. This section is positive, so it has to be above. This section is a negative slope, so it has to be below. Positive, above, negative, below. And then you can If it's a polynomial graph, like these ones, in your head, you can be like, this is a 4th degree polynomial. So if I take the derivative, it goes down by 1, so it has to be a cubic. That's the shape of a cubic graph. Yeah? All right. We okay? Now let's. Was there a question?
No, I was.
Okay, let's get away from polynomials now. All right. So this is our f of x. We're going to sketch it on a separate graph because it'll be a little weird overlapping this one. All right. How does this look different? Or what is the major... Oh, I'll wait till you copy it down first. Okay, sharp turn. Okay. Yep. All right. No, it's not supposed to be just below the sharp turn. Is that what you're asking? It's a function, but it's a weird function. Let's say there. And we'll say this is 3. There we go. Okay. So this has a sharp turn in it. What do we know about sharp turns for their derivatives? They're undefined. They don't exist. Okay. So the
go over that one more time, why it doesn't exist.
I'll tell you after.
Okay.
Wait, so is that
Okay.
is it going downwards at an end?
Yeah. Okay. Which one? Which part do you mean?
Like the end.
This bit?
Yeah.
Yeah. Okay. This is a straight line. Right? What do we know about straight lines? The slope at every point is constant. So what's the slope of this line? 1, right? Does everybody agree with that? Right? If you do rise over run, oops. You do your little triangle and you get m is equal to 2 over 2, so it's 1. So the slope on that line all the way up to 3 is 1. So the derivative graph has a value of 1 all the way to 3. Does that make sense? Okay. At 3, weird stuff happens, right? Because we get a sharp turn, and we know the derivative doesn't exist, so that's why there has to be a hole there. That point cannot be on the derivative because derivatives don't exist at sharp turns. Okay. Is this a positive or negative slope? Negative, right? So it's a negative slope. Now, what does it look like the slope here is getting closer to at this bit? Coming from this side, coming from the right side. Sorry? smaller and smaller. It looks like if you kept going, it looks like it would want to go. You can't see. It looks like it would want to do that, right? And it would look like a max. So like it's getting closer to 0. Okay, does that make sense to everybody? It looks like it's going to flatten out. So that means on the derivative, we got to start at 0. But it's an open circle because the point doesn't exist. Then the slope is negative and it keeps getting steeper, right? It's shooting down. So it's below the x-axis and it keeps firing down. That's the derivative graph. Does that make sense? Right? This is whenever you see a straight line, it's a constant slope. So if you rise over run, you get it. It's going to be a horizontal line in the derivative. And then because this is a sharp turn, that point doesn't exist, so it has to be an open hole. This is getting closer to 0. We never get there because you never get to that peak, right? So it's on the x-axis at 0, but again, an open circle. And then because it's a negative slope, it just shoots down. All right? All right, we're going to do another one. So this is f prime of x. Okay. So we got f of x here. It's got, what does it have in it? What is this one? How is this one different than all the other ones you've seen? It's got a vertical asymptote right at the origin, right? So we can even mark that down if we... So, do vertical asymptotes have derivatives? No, they don't. Okay, so let's just look at the left side. What's the slope here? Pretty close to 0, like really small. And then what happens as we move along it? It starts to get larger and larger, but it always stays positive or negative. Positive. This is all positive slope, right?
Yeah.
But it gets really, really steep, like almost vertical. Yeah. So on the left side, it's coming this way, and then it just starts shooting up again, right? But you never get to this point, right? Because that point doesn't exist. So this one still has that vertical asymptote. Okay, now look at the other side. You always read graphs left to right. So then we start here. Is this slope positive or negative? Negative. Really high or really small negative, like negative 1 billion. And then what happens to it? It gets closer to 0. So it starts as a really, really small number and gets closer to 0. What does that look like on the graph? It starts down here, and then it comes really... starts like that. This is f primed. Right? Positive, it gets really big. So the positive gets really big. Negative slope, so it has to be below the x-axis. Starts out really small and gets closer to 0. Starts out really small and gets closer to 0. Yes? I know these hurt the brain. You got to think about it sometimes, but that's okay. That's why I wanted to do this. All right, this is the last one before I give you some practice.
Does it have a VA also?
Which one?
That one? Because it's not touching zero.
This one?
Yeah.
Yeah. Right there.
No, like,
You mean in HA?
yes.
Yes. Yes, it does. I just didn't draw it, but yeah, it does. Okay. Here's our f of x. Whoops. Do you want to try this one on your own? You try to sketch f prime of x. So you got it?
At the middle is the slope 0.
Okay, my sketches are never good, but.
Let me accentuate this just to point something out.
Oh, man.
Is that tan stuff?
It's not a tan graph, but
Okay, mine looks awful, but I think it's right.
what's the slope at the origin? That's a saddle point or a point of inflection that we learned about in grade 12.
Isn't it like kind of two? Like maximum?
Hmm?
Wait.
All right. You ready? What's the slope here on this side? Is it positive or negative? It's negative. This has negative slope everywhere, right? The whole graph is negative everywhere. Starts out really high and it gets closer to 0. So we come up this way. After 0, after you get to 0, the slope starts to increase in a negative direction again, right? Because it's negative 0, negative 1, negative 2, negative 3, and it starts shooting way down. So the graph literally just does this. Do you know what the equation of this graph is, Matthew?
X cubed.
Yeah, it's x cubed. In fact, it's negative x cubed, though.
Wouldn't that mean it has two, like, maximum?
Nope, because if you take the derivative of that, what's the derivative of negative x cubed?
No,
Negative 2x squared. That's a parabola that opens down. So
oh, I meant like two. Maybe like. Because the other one was like.
oh yeah, it's that type.
Okay. Yeah.
If it has x cubed plus a bunch of other stuff, then you get that. If
Then you get the
it's
two
just
points?
yeah,
Okay.
but if it's just x cubed, it just goes through the origin like that.
Okay.
Yeah. All right.